AI research moved fast this week. We cut it down to the 7 papers that actually matter, ranked, counted down, with the verdict on each. Let's get into it. Number 7. Hand it one photo and a video and your character moves exactly like the person in that clip. No rigging, no skeleton. This is about controlled character animation, making a still character copy the motion from a driving video. The usual trick is to strip the driving video down first, trace a posed skeleton, mask out the background, then animate from that. But every time you simplify, you throw information away and the result drifts. Scale 2 skips the middleman. It feeds the raw driving video straight into the model and lets it read everything it needs. Pose, environment, detail directly. To train it, the team built a 60,000 clip dataset that folds different animation tasks into one, and added a preference tuning step to clean up the fine details. The payoff, across a range of character animation tasks, it substantially beats the previous state-of-the-art. For anyone building avatars, virtual try-on, or motion tools, this is a cleaner pipeline to start from. One model, raw video in, animation out, verdict, read. Number 6. The 30B open model just beat much bigger ones at deep web research by learning to delegate. This paper is about deep research agents, AIs that browse the web for you, chasing a hard question across dozens of pages before they answer. The catch is the context window. One agent reading everything itself runs out of room on a long hunt and the trail goes cold. SearchSwarm trains a manager instead. A main agent breaks the question into subtasks, hands each to a sub-agent, and gets back only a short summary so the big picture never overflows. They built a harness to synthesize that delegation data, then fine-tuned a 30B model on it. The payoff? 68 on BrowseComp, the toughest browsing benchmark, the best of any model its size. If you build research or search agents, the delegation recipe is the takeaway and the weights are open. Verdict, read. Number 5. An AI coding agent jumped from 59 to 78% by grading its own work with no answer key. This is about the agent harness, the skills, tools, and workflows an agent leans on, and the thing you keep tuning to handle new tasks. The catch is that tuning normally needs labeled answers to score against, and in real deployments you rarely have them. So the harness stops improving the moment you run out of ground truth. Their method, RHO, optimizes in the dark. It mines an agent's own past attempts, picks a core set of the hardest cases, and resolves them in parallel. The agent checks itself with self-consistency, drafts harness updates, and picks the winner by its own preference. No human grading anywhere. One round took SWE Bench Pro from 59 to 78%, and it provably targets the agent's prior failure modes. If you ship agents and can't label everything, this is a self-improvement loop you can actually run. Verdict, read. Number 4. AI can already reason about an experiment. This one tries to actually run it, pipettes and all. This paper is about vision language action models, robot brains that look, read an instruction, and then move. Today, LabVLA lives on a screen. It reads papers and plans experiments, but the physical work, moving samples, operating instruments, stays in human hands. And the models that do control robots aren't trained for the precision a bench demands. LabVLA takes that on in 2 stages. First, it teaches a vision language backbone to think in actions, then it bolts on a motion expert for smooth continuous control. To feed it, the team built a simulator that composes whole lab tasks out of atomic skills. The payoff, the highest average success rate of any model they tested, both on tasks it trained on and ones it had never seen. For builders, this is the opening move toward a robot that does the science, not just plans it. A promising direction, not a lab tech yet. Verdict, read. Number 3. If an AI could run a whole research project on its own, for hours, and actually get better as it goes. That's autonomous research, is an agent forming hypotheses, running experiments, and learning from the results without you in the loop. The catch is memory. Most agents forget what they tried, so they loop on dead ends and never compound their own findings. Arbor fixes that with a hypothesis tree, a living map that links every idea to its experiments, evidence, and lessons. A coordinator steers strategy while throwaway executors test each branch in isolation, so a failed run can't poison the rest. It tops every one of 6 real research tasks, more than doubles the held-out gain of rival systems, and hits 86% any medal on a machine learning benchmark. If you build research or experiment agents, the persistent memory design is the part to study. Verdict, read. Number 2. Search agents on made-up questions, and they keep finding sneaky ways to cheat them. Deep search agents are supposed to dig through evidence step by step before they can answer. That's the skill we want to teach. But synthetic training questions leak. The answer is often guessable from one clue or already sitting in the model's memory, so the agent skips the searching entirely and learns nothing. FORT builds questions that fight back. It picks entities, wires up an evidence graph, writes the question, then adversarially refines it to close the 4 ways an agent could shortcut: co-covered evidence, single clue giveaways, exposed constants, and prior knowledge. Trained on that data with plain fine-tuning, FORT Searcher tops comparable open-source search agents and actually searches longer before answering. If you train search or research agents, the task synthesis recipe is the takeaway. Verdict: read.
Okay.
Number 1. AI just outscored human gold medalists at the International Math Olympiad, and this paper shows how. This is about formal proof generation, not just getting the right answer, but writing the full argument that holds up to scrutiny. The hard part is checking. Most models can spit out a proof, but they're terrible at telling a sound one from a plausible-looking fake. MaxProof trains one model to do 3 jobs: write proofs, verify them, and repair the broken ones. Then at test time, it generates a whole population of candidates and runs a tournament to pick the survivor. The result clears the human gold medal bar: 35 out of 42 on the 2025 Olympiad, 36 on the USA Olympiad. If you work on reasoning or verification, the Generate-Verify-Repair loop is the idea to steal here. Verdict: read. That's the week's research, cut down to what's worth your time. New papers every day, the best of them every week. Subscribe for the weekly paper cut.